Hello, this is Mrs. Gregory. This is for my 8th grade class. This is the answers, truthfully, to practice set 35 on page 233, and we're going through problems A through K. Make sure that you've done this already. Let me go ahead. I know I put some answers there already. I didn't mean to do that, but I wanted whoever, if you did not have a book, you have it in front of you. I want you to be able to do these problems before I go over them. So if you haven't done that, shut off this video and start the work. All right, there's A through F, and if those of you who did not get a chance, here's G through K. I want you to see that. All right, does everybody see that? Okay, let's go ahead and get started. All right, now, first thing I did was I'm looking at these pictures, and I've decided that I'm just going to use the pictures in your book and I'm not going to redraw them. You can redraw them, but personally I have a difficult time drawing these things. All right, so but I'm going to go ahead and pull these out, and it says refer to the following figures for problems A through E, and you want to look at these triangles. All right, this is a right triangle, right triangle, right triangle. This is an equilateral triangle. Okay, so I want you to see that this is neither congruent nor similar to the rest. So this is our odd man out, just making sure you're getting a good vision of this. Now, it turns out that triangle ABC and ZYX, those two are the same size. They are congruent. They just look and face in different directions. They're about the same size. We're just going to have to make these assumptions. And then you see this triangle PQR, right? PQR goes with ACB. These two triangles, they're all similar. This one's just a little bit bigger, all right? Now, it says, first thing, which triangle is congruent? All right, I rewrote the question. It says, which triangle is congruent to triangle ABC? Which triangle is congruent? Congruent meaning that, oh, let me do this better. I'm going to take that off so you can see it better. All right, so I'm looking at this. It says, which triangle is congruent to ABC? And when I look at ABC, the triangle that is congruent is XYZ. Now, and because I'm just asking for congruency, it doesn't matter the order of the letters, because I want you to make sure when we do a congruency statement, all right, then we have to have congruent angles in the same order. So right now, because all we're doing is saying which triangles are congruent, and we're not really specifying a congruent statement, then what I can say it's XYZ, all right? So this is correct if you went with triangle XYZ. Some of you might have written ZXY, which is correct also, all right? But it still refers to the same triangle, all right? Let's go to B. Which triangle is similar but not congruent? Again, I'm gonna look at the similar, and it's similar to XYZ, but it's not congruent, would be the larger one, and I just put PQR. Again, I'm not making a statement. I'm not telling you which angles correspond to which angles. I'm just telling you that these two triangles are similar to each other. All right, then the third question says, which triangle is not similar? All right, that's pretty obvious. Which triangle is not? We're going to say JKL because it's a completely different shape. All right. All right, let me go on to D. Hopefully you guys are getting those first three. They're not terribly difficult, but it can be a little bit technical when we start talking about congruent points and congruent sides and angles and all that stuff. Which that's where D comes in. Let's go ahead and read it. Let me see if I can pull that up a little bit more. It says, which angle in triangle ZYX, all right, ZYX, corresponds to angle ABC. Notice Z, Y goes with B, and X goes with C. All right, they're asking which one. So if I set up a congruency statement, I say that triangle ABC corresponds with ZYX. And if I set it up this way, I can tell you that angle A corresponds with Z. That's the main answer, but I can continue and say that angle B corresponds with Y, and angle C corresponds with angle X. Okay, so if I completed that, this congruency statement makes sure, you have to make sure that your corresponding angles are in the same order, okay? Again, with this same idea, all right, I'm going to go down to E, and I'm going to go ahead and fold this paper so I have more room. E says, which side of the triangle PRQ, let me go ahead and do that, which side of the triangle PRQ corresponds to side XY in ZYX? So let me pull that up here, all right? It says, which side of PRQ, and I'm going to look at PRQ, corresponds to side XY in ZYX. Notice PR, that's my hypotenuse, and it goes with my hypotenuse ZY, all right? And it looks like PQ corresponds with ZX. And so here it's asking specifically XY. Who corresponds with XY? But QR, right? These two are corresponding sides, and it shows it even in my similarity statement. Notice I have RQ goes with YX. I could say XY goes with QR. They are the same. Then I wanted you also to notice that PR corresponds with ZY, right? And at PQ, these two on the end, PQ corresponds with ZX, all right? That's also important. Okay, now I'm going to go on to F. This is a little bit more intricate a question because it says, are these two triangles similar and how do you know? So I went ahead and I set this up in a different picture. Let me make sure it's in your book or you get the whole picture because sometimes it comes out. It says, are these two triangles similar and how do you know? So I set up you have to set up proportional fractions with corresponding sides. And I just did this kind of throwing it together. I said, here's my small triangle, here's my large triangle. I said 5, let me get a pen here because that might help. If I take here, the red pen might be easier to see. I'm telling you that from looking at this side corresponds with this side. I'm not saying they're the same side, I'm saying they correspond. I'm going to tell you that 3 corresponds with the 6 and that this 6 corresponds with the 15. Now, we can determine if they're similar if I can set up fractions, all right? 5 over 12, this is this side, and then I did 3 over 6, and then I did 6 over 15. There's my 3 fractions, all right? Are they proportional? When I say are they proportional, are they equivalent fractions? So one thing I can do, and I did here, is I reduce them. 5/12s can't reduce, but 3/6 does reduce to 1/2, and 6/15 reduces to 2/5. And guess what? These fractions are not equal. So the answer to this is no, the lengths of corresponding sides are not equal. And why? Because my proportions are not all equal. All right, so this is very important. All right, when I can put 2 sides, make a fraction, get 2 corresponding sides, make a fraction, get the other set of corresponding sides and make a fraction, those fractions have to be equal for these to be similar. All right, and please take note that all the lengths, side lengths of the small triangle, I put them all in the numerator, and the side lengths for the large triangle, right, they're all in the denominator, and that's important. All right. All right, let me move on and go on to G. All right, let's find G. All right, let me find G because G is very intricate. All right, so let's go to G real quick. It says these quadrilaterals, let me put it in the book right here. It says these quadrilaterals are similar. All right, let me make sure I got this here. These quadrilaterals are similar. Find the missing side length. What is this? And then what is the scale factor from the smaller figure to the larger figure? And they're telling me that the units are in inches. All right. So here's the picture. All right. I tried to draw it, not so great, but I went ahead and did a drawing of it. Let me move my book so it doesn't take up all this extra room. And I'll fix it in just a minute. It says these quads are similar. This is an important statement, okay? It tells me that if these quads are similar, then any of the proportion, any of the fractions I make using the side lengths, they better be equal, okay? So because of that, I can say find a missing side. So I went ahead and set up a proportional fraction. I said with my small and my large. And what I did, I said that this side corresponds with this side corresponds with this. Okay, I used those two sides. I've got two more. I could say 3 goes with 9 and 5 goes with 15. But I wanted to start with these two sides. I said this side 3 corresponds with 9. And I said this side 4 is a small, corresponds with X. You can see I already messed up a little bit, but I think you can figure that out. Let me make sure I put that as a 4 and this is X. Now, when we've got a proportional statement like this and we're missing a side, what I want to do is I'm going to solve for X using cross products, which means I'm going to multiply 3 times X is going to equal 4 times 9. Okay, and so that's what I did. I set up 3 times X equals 9 times 4. All right, and then I solve for X. 3x is equal to 36, but I don't want 3 x's, I only want 1. So I divide both sides by 3, which gives me 1x equals 12. All right, 1x equals 12. Could have done a little bit different. I could have said these two sides, 3 over 4, how does it equal to 9 over x? This is another proportional statement. It's just done a little bit different. Your book may have done it this way, but again, I'm going to end up with 3x equals 36, and guess what? X still equals 12. All right. Now, the second question says, what is the scale factor? So let me do something a little different. It's not really difficult, but technically I can look at it and go, well, from 3 to 9, I multiply by 3. From 4 to 12, multiply by 3. 3 to 9, multiply by 3. 5 to 15, I just multiply the small side by 3. So I went ahead and just made a little chart, and I used my corresponding sides. Notice to go from 3 to 3, I notice that for every small side, we multiply that by 3 to get the largest side. So therefore, 3 is the scale factor. All right, this is not terribly difficult, but sometimes you got to see it, and sometimes the numbers aren't nice and neat. So let me go ahead and show that to you again with the picture. All right, so you see how I set up my little table, and these are corresponding sides. I went ahead and I just put 3 here, and I'm gonna put 4 here. So you see that those are corresponding sides. That might be helpful. Okay, now I'm gonna go on to H. All right, H says they wanted me to draw 2 rectangles. Please do not be lazy about this and be as precise as you can. All right. It says draw 2 triangles, one 2 centimeters by 1 centimeters, and draw the other 4 centimeters by 2 centimeters. Then answer the following questions. And really, you're just going to answer H, I, and J. K is a completely different question. But I'm going to go ahead and give you the picture of what I've gotten. And I drew this as best I could. All right, it says draw 2 triangles. One's 2 centimeters by 1, and the second one is 4 centimeters by 2. So I drew it, and I actually used my handy dandy ruler. And if you'll notice, this is 2 centimeters by 1 centimeter. I can't pick these up. Yeah, 1 centimeter, and this side is 4 centimeters by 2. All right. I expect you to do this. This is not difficult to do, but it's something that you guys should be able to do. So there's the drawing. Then the question says, what is the scale factor from the smaller to the larger? Now, it's not terribly difficult because I take the smaller and I notice that that corresponds with that side and this corresponds with this side. I ask myself, if I take the smaller one, how can I get to the large one? I multiply by 2. I go from the smaller side, and my corresponding side is 4, and again, I multiply by 2. So my scale, therefore, I'm going to put this thing here. It's a 3 thing. It says, therefore, the scaled factor is equal to 2. All right? That's not terribly difficult. And remember, if the scale factor is a whole number, is greater than 1, then the resulting figure is going to be larger. If the scale factor is going to be less than 1, but greater than 0, right? If we'd gone from larger to smaller, my scale factor would have been a half, 1 over 2. All right, 1 over 2, because we would have divided this by 2 to go the other direction. All right. Okay, let me go ahead and get I and just leave it here. I got it. I'm going to leave my picture there so you can see it, and I'm going to put I there. I says the perimeter of the larger rectangle is how many times the perimeter of the smaller rectangle. So what we want to do is I look at that. First, I got to find the perimeter, and we know how to find the perimeter. It's the distance around the object. So I go around, and it's 1 plus 2, 1 plus 2. It turns out the perimeter of the smaller rectangle is 6 centimeters. The perimeter of the large one, again, doing the same thing, 2 plus 4 plus 2 plus 4 gives me 12 centimeters. And it turns out that the perimeter of the large rectangle is 2 times larger than the perimeter of the small. All right, I could have said 12 divided by 6. I notice that it takes me, I have to multiply it 2 times. And notice in perimeter, your perimeter is the same thing as your scale factor. It's a little bit different. Then for J, they asked the same question kind of, but this time they asked for area. Remember, perimeter and area are different. Area, we obtain the area by multiplying the length times the width. And the question says, the area of the larger rectangle is how many times the area of the smaller rectangle? I want you to notice something. When I did this, the area of the small is 1 times 2, 2 centimeters squared. Let me pull this up if you can't see it. And then the area of the large is 2 times 4, which is 8 centimeters squared. And it turns out that the area of the large is 4 times greater than the area of the smaller rectangle. And that's important. And if you'll notice, it's actually 2 squared. This was 2 to the first power. This is 2 squared. Some of you might see that pattern. As we get into algebra, we start looking for patterns and things. Okay? All right, and then the last question I have is K. All right? K says, let me go ahead and pull the book back over and make sure I've got it in here that you can see it. K says, on a scale drawing of a house, 1 inch represents 8 feet. How wide is the garage if it is 2.5 inches wide on the drawing? Okay, so it's very important. This is a scale drawing. All right, it's like a blueprint of a house. All right, it tells me that 1 inch is equal to 8 feet. All right, so when I'm doing word problems like this, my deal is to write down what I know and then determine what am I looking for. So what do I know? I know that in my scale drawing, all right, 1 inch is equal to 8 feet. All right, make sure I've got that. Now, how wide is the garage if it is 2.5 inches wide on the drawing? All right, let me put an S there. If it's 2.5 inches, all right, that's what I have. I really want to turn it into feet. All right, so technically what I'm doing is taking my scale drawing. This is my scale, or taking my scale, not my scale drawing, and I'm going to set it up so that I'm going to put, just like if I were doing a conversion unit, and I said, put my conversion unit here. Some of you will say, oh, Miss Gregory, you just multiply by 8. And that's true, but I wanted you to see that when I do this, my inches go away. I'm left with feet. So I rewrote it, and I said, instead of saying 2.5, I said 2.5. Most of us know this. It times 8 feet gives me 20 feet. All right. So from looking at the picture, all right, that's what the picture is only 2.5 inches, but in reality, the garage is 20 feet wide. Okay, so that's how I got it. 2.5 times 8 is 20 feet. Okay, guys, that's what I've got for now. Again, if there's any extra questions, you guys want to see some more or need more practice, you can go to some of those YouTube sites that I have pointed out before. I believe Let me see if I can find the page that has that. Oh, I don't see it. So anyways, I'll pick it up later and I'll get it to you, but one of them is Math Antics. Look for Math Antics. And there's another one you could try, Khan Academy. But let me go ahead and finish this off. And, all right, have a great day. Bye now.